Now finally, to complete this module, let's talk about orbital elements. For two-dimensional elliptical orbits, the geometry of the orbit is specified by the semi-major axis and the eccentricity. So the semi-major axis, right, the line from C, from the center of the orbit to either perihelion or aphelion along the line of apsides, and the eccentricity, which is the distance between the center of the orbit to the sun in units of the semi-major axis. Now, in this case here, we oriented the x-axis with the perihelion. Now, imagine that this is not the case. Then you're going to need one extra quantity, which would be the argument of the perihelion. Imagine that we have an orbit like this that has changed its orientation with respect to the axis that you're using to measure. Now, in this case, you have this extra angle here, which goes from whatever is the system that you're using for the origin of your coordinates to the perihelion. So this angle omega is called the argument of the perihelion. And then from the perihelion to the planet, you measure the true anomaly. So these four quantities would specify the orbit if you have the plane of the orbit also, if the plane is given. Now, for an orbit at the ecliptic plane, indeed this suffices. But if the orbit is inclined, then you need two extra parameters to specify the three-dimensionality of the orbit. These are the inclination and the longitude of the ascending node. In 3D space, these are the elements of the orbit. Again, you have in the orbital plane, you have the argument of the periapsis, the true anomaly. The shape of the orbit is given by the semi-major axis and the eccentricity. Now you are measuring the periapsis, the argument of the periapsis from the longitude of the ascending node. Usually you take the reference direction to be the vernal point, and the longitude of the ascending node is measured from the vernal point to the longitude of the ascending node. The ascending node is the point here where the orbit crosses the plane of reference, say the ecliptic, with the planet going up towards northern ecliptic latitudes. On the other side, you have the descending node, and this gives you the line of the nodes. The inclination is the inclination of the orbit with respect to the plane of reference. The six elements, semi-major axis, eccentricity, inclination, argument of periapsis, true anomaly, and longitude of the ascending node, completely specify the orbit in three-dimensional space. As we're going to see in celestial mechanics, these can be converted into position and velocity. Because these are vectors, you have three positions in space and three components of the velocity vector. Again, six quantities. They can be translated into these six orbital elements.